Hi guys, in this video we're going to have a look at reciprocal graphs. So reciprocal graphs is in this format here where it's y equals and then it's something divided by x, and they always look the same. In an exam, you're probably not going to be asked to plot them. You're just going to be asked to basically identify them. They might have like a quadratic, a cubic, an exponential, and a reciprocal graph, and you'll just be able to have to try and spot which one is the reciprocal graph. But we'll do a bit of plotting anyway, just in case, and obviously it will help you then identify them when you have the four different ones to try and pick from. So let's get started. So here's our first one. We have y equals 3 over x, and again I've got my little table here. If you don't have a table, obviously just like with straight lines, quadratics, exponentials, or cubics, just make sure you just draw a little table here just to help you get a few points to plot. Okay, so let's get going. So let's start with the first one. Well, let's start from 0. We normally always start from 0, so let's start from 0. And in this case, it actually is quite an interesting one, because if you do 3 divided by 0, you can't actually do that. It doesn't actually, there's no actual value. In fact, we actually could say that's not applicable, because how many zeros go into 3? You just can't do it. And that's crucial for how this graph is going to look. Let's carry on doing the positives. So I'm going to have 3 divided by 1, because x is 1 in this case, which just gives me 3. And then I'm going to have 3 divided by 2, which is 1.5 or 1.5. We can keep it as 3 over 2, that's absolutely fine. I'm just going to put 1.5 because it'd been easier to potentially plot. And then we've got 3 divided by 3. Obviously simplified, that's going to give me 1. And then 3 divided by, when x is 4, is 3/4. I'm just going to call that 0.75. Again, just to make that a little bit easier to see. And then going backwards, do the negatives. We're going to have 3 divided by minus 1. So 3 divided by minus 1 is minus 3. And carrying on, we have 3 divided by minus 2. So that's just minus 1.5 or minus 1.5. And 3 divided by minus 3, simplified, gets me minus 1. And then finally, 3 divided by minus 4 is minus 0.75. And all I'm going to do now is plot those points. So I can't do anything when x is 0. So on the y-axis I can't do nothing. And I'll talk about that in a bit more detail in a minute. When x is 1 we have 3. And 2 is 1.5. 3 is 1. And 4 is 3/4 or 0.75, which is roughly there. And then over here, when we have minus 1, we have y to be minus 3. Minus 2 is minus 1.5. Then minus 3, minus 1. And then the minus 4, minus 0.75. And then we need to join these up. But this is where it's slightly different. Okay, if I, again, turn your paper so you can get your nice curve with your wrist going through the points, like so, and with this one here, there we go. So, this is what a reciprocal graph looks like, and actually, the closer you get to the y-axis, or the closer you get to x equals 0, in fact, this will get closer and closer and closer and closer to the y-axis, but it will never actually touch. Same with this one here. This will get closer and closer and closer and closer and closer, but it will never actually touch, because when x is exactly 0, you can't actually do it. There's not actually a value. So these curves will get closer and closer and closer but never touch. Likewise, these ones here will get closer and closer and closer to the y-axis, but again won't actually touch. And that's what a reciprocal graph looks like. So that's the most traditional one, when it's like this and like this. There are a few different alternatives which we'll have a look now, including our next example. So again, I'm going to plot this. When x is 0, minus 2 divided by 0 we can't do, it's not applicable. It's not actually a calculation that will work. Then I've got minus 2 divided by 1. That's of course going to give me minus 2. And then I'm going to have minus 2 divided by 2. Well, that's going to give me minus 1. And then minus 2 divided by 3, that's just minus 2/3. Keep that as the same, or minus 0.66666, whatever you prefer. Minus 2 divided by 4, well, that's minus a half, or minus 0.5. And then we're going to do the negatives here. So minus 2 divided by minus 1. A negative divided by a negative is a positive. So that's just 2 divided by 1, which is 2. And then minus 2 divided by minus 2. Again, I've got a double negative. 2 divided by 2 gives me 1. And then minus 2 over minus 3. Negative divided by negative is a positive, so that's just 2/3. And you might have already guessed it. Minus 2 divided by minus 4 is going to give me positive 1/2. So if I now plot those, 1 is minus 2, which is there, yep. 2 is minus 1. When x is 3, got minus 2/3, which is roughly about there, and then minus half there. And minus 1, 2 is there. Minus 2, 1 is there. 2/3, roughly there, and roughly there. So again, when I draw this, obviously I can draw my points like so. And again, if that was to continue, it would get closer and closer and closer to the y-axis. And this one here, again, just going to draw it, would get closer and closer, closer to the x-axis that way, closer to the y-axis this way, but never actually touching. And exactly the same here. I'll just join those points up. It's going to keep getting closer and closer, but not. And again, this one here is going to keep getting closer and closer, but not actually touch. And the difference is obviously here, it was like this, and it's sort of like, in other words, some sort of rotation here, or reflected in the y-axis, so it's now this side and this side. And the reason for that is here it was a positive number, and here it is a negative number. Okay, so just a little bit of something to be aware of. You can have it that way and that way, but you can also have it this way and this way if it's a negative. Okay, so we've got 2 more examples to have a look at where it doesn't quite follow the fact that we go into it doesn't quite meet the y-axis, doesn't quite meet the x-axis. There are a few examples where that doesn't quite work. So let's have a look at those. And they are these ones here. So little bit of a difference is obviously we have our reciprocal here, and that would mean that we wouldn't touch the y-axis, we wouldn't touch the x-axis. But because I've got to add 2, it does actually change what this looks like. Only subtly, but it does change it. So in this case, if I do 1 divided by 0, and then I need to add 2, but 1 divided by 0, I still can't do that. It's still not applicable. So if I can't actually do it, even if I add 2 to it, it still doesn't work. So that's still like the same. And then 1 divided by 1 is obviously 1, but then I need to add 2 to it. So that gives me a 3. And then 1 over 2 is a half, plus 2 is 2.5, or 2.5, however you want to write it down. 1 over 3 is obviously a third, plus 2 is 2 1/3. And then obviously I have 1 over 4, which is a quarter, plus 2 is 2 1/4. And then I'm going to do the negatives. So I'm going to have 1 over minus 1, which will simplify to be minus 1. Then I add my 2, gives me 1. And then I'm going to have 1 over minus 2, so that's going to give me minus a half, plus 2 is 1.5. And then I'm going to have 1 over minus 3, which just gives me minus a third. So I'm going to add 2 to have... hang on a minute. So that'd be 1 2/3. Sorry, I'm just trying to do that in my head there. Yeah, 1 2/3. And the next one, I'm going to have 1 and minus a quarter. So that's going to be minus a quarter plus 2, which will be 1 3/4. Cool. Okie dokie. So let's plot that and see what we have. So 1, 3, 2 and 2.5, or 2.5. then 3 and 1/3. When x is 3, we have 2 and 1/3, which is there. And then 2, when x is 4, we have it to be a quarter. Then I have, when x is -1, we have 1. And then we have -2 and 1.5. Then 2, when x is -3, we have 1 2/3. And then 3/4. So just try and do the, that probably should be a little bit lower. I probably plotted that point a bit wrong there. Apologies for that. Okay, so then let's draw our curve. So it's going to get very close to that one and then go up like so. Again, not touching. And this one here is again going like this. And then that will come round and again it will get very close to the y-axis, but it won't actually touch. Okay, so in this case it still doesn't touch the y-axis. Okay, it keeps going here, gets closer and closer, doesn't touch it. Here gets closer and closer, doesn't touch it. But in this case, because we've added 2, basically instead of being like we previously had where we didn't touch the x-axis, it would carry on going. Here, because we've added 2 to everything, all of the y coordinates have added 2, so actually we don't ever touch the, basically if you imagine a line going across where it's y equals 2, we never actually touch that line, and that's because of this +2. Okay, so it's just a very subtle change. Rightio, let's have a look at the next one, which is this one over here, which is our last one. And this time, again, it's not just 4 divided by x, it's 4 over x minus 1. So there's a little subtle difference here, and it does make it look a bit different. So let's have a go. So if x is 0, I'm going to obviously have my 4 divided by, but if x is 0, 0 minus 1 gives me 4 over minus 1, which of course I can actually do. That's just going to give me -4. And I'm going to do the positive numbers. If I then have 4, and then if x is 1, take away 1, that gives me 0. So this time that's 4 divided by 0, and as we've said before, whenever you divide by 0, you can't actually have anything, so that's not applicable in this particular case. Then I'm going to have 4 divided by, and then if it's x is 2, 2 take away 1 is 1, so that's just 4 divided by 1, which is 4. And then next one, when x is 3, 3 take away 1 is 2, so it's 4 divided by 2, which is 2. And then 4 divided by, if x is 4, take away 1 is 3, so that's 1 and 1/3. And then if x is 5, take away 1 is 4, so 4 divided by 4 is 1, so that works out quite nice. Doing the negatives then, so I'm going to have the 4, and then if x is -1, so -1 will give me -2. So 4 divided by -2 is going to give me -2. And then if x is -2, -2 minus 1 gives me -3. So that's going to give me -1 and 1/3. And I'm going to keep going. So if x is -3, -3 minus 1 is -4. So 4 divided by -4 is -1. And then the final one on this one, if x is -4, -4 minus 1 is -5. So I'm going to have -4/5 or -0.8 when I convert it to a decimal. Okay, let's have a look what this looks like when we plot it then. So this time I actually can plot the point when x is 0, because it's going to give me -4. Sorry, here and there. And then one I can't do. And then x is 2, y is 4, which is there. And when x is 3, y is 2, which is there. And then 4 and then 1 and 1/3, which is roughly there. And 5 and 1, which is there. Lovely. And already done the 0, so when it's -1, we have -2. And then when we have -2, it's -1 and 1/3, which is roughly there. And then we have, when x is -3, we have -1. And then the minus 4/5, which is about there. So let's plot that. Again, they're all getting closer to the x-axis here. So it's going to be something that looks like that. And because this time when x is 1, you can't do it. Imagine there's a nice vertical line going through x is 1. It's going to get closer and closer and closer, but never actually touch. And it's the same thing with here. It's going to get closer and closer to the x-axis, go through my points. This time I can go through the y-axis, but it's going to get closer and closer to the line x equals 1. So because of this action here of with x minus 1, everything is actually shunted 1 to the right, and that's to do with graph transformations, which you can check out in my other video. But just to give you a heads up, it doesn't always look like our first two examples, where it's like getting closer to the x-axis and the y-axis in each one, even if it's the other way around. Sometimes you can have it slightly changed to do with graph transformations. But essentially, with a reciprocal graph, it will always be getting closer, but never actually touching a particular part. So it always comes out with curves like so. So that's reciprocal graphs. Reciprocal graphs. Hopefully that helps, and hopefully that explains a few things. Always use a pencil when sketching these, just in case you do what I did there and make a point that doesn't quite look right. Okay, so just make sure you use a pencil in the exam in case you need to rub it out. Thanks for watching, guys. Cheers.